Now that we explained how the heating occurs, let's look at the distributions of heating in the zonal, mean, meridional, and the tropical and extratropical zonal sections. As you can imagine, the latent heating is related to evaporation, which is maximum in the subtropics. So you can see the distribution of the latitudinal distribution of zonal mean latent heating shows this double cusped distribution with maximum energy being picked up in the evaporative latitudes, whereas the heat produced by precipitation is going to be very strongly seasonal dependent and going to be having this distribution because it is being released in the ITCZ where maximum rainfall happens when you do the zonal means. Of course, you also see the mid-latitude storm tracks here, and there is a seasonal dependence. So in the northern hemisphere summer, you have a strong northward shift of the ITCZ, and there is a minimum in the rainfall heat release in the southern tropics, and there is strong storm track here in the mid latitudes, whereas there is a strong energy release, heat release in our heating of the air column under the ITCZ, which is pretty strong, 10 to the 14 watts averaged. In DJF, obviously you shift the ITCZ with the sun on the zonal mean sense. You remember the Atlantic, South Atlantic convergence zone, South Pacific convergence zone. So there are zonal asymmetries, but we will just look at the zonal means. So the northern hemisphere ITCZ goes into a minimum. The southern hemisphere ITCZ gets the maximum heat release, heating from the rainfall. And there are changes in the distribution of maximum evaporation as well corresponding to that convergence. And you have stronger extratropical storm track, mid-latitude storm track here corresponding to a similar one in the southern hemisphere. Looking at total column heating now for again June, July, August and DJF, we are still having the the heating by the rainfall and the net heating that we formulated before, and you can see that the sensible heat is basically a small part of this overall net heating, you can see, and the net radiative forcing is here, okay, in June, July, August. So in DJF things change, as we remember the heating by the rainfall, net columnar heating, and sensible heat still remains the same. You can see the little changes that happen at higher latitudes, but low latitudes remain almost the same. It's just the difference between, let's say, land and atmosphere, ocean and atmosphere, that's driving this small sensible heat dependent on wind and the temperature difference. Obviously, temperature differences are typically very small over the ocean and can be massive over some parts of land like deserts, or when you have storms passing by and so on. Okay, so you can see the distribution makes sense in terms of producing the circulation and the net heating that is used up. Energy coming from the sun and being lost to space is converted into latent and sensible heating, and latent heating is basically converted into atmospheric heating by precipitation process, which is the biggest driver of local and remote forcing. Why am I mentioning that? Because during an El Nino we'll see that this atmospheric heating by precipitation shifts and produces global teleconnections via waves and changes in the Hadley and Walker cell and so on. Just to conclude that thought, looking at the latent heat release by precipitation process and condensation heating by the precipitation process and sensible heating for the equatorial zonal section and at 25 north, looking at the various terms, you can see that sensible heat here remains small, but the seasonality of the heating by the rainfall process again shows the strong contrast of the ITCZ movement and the overall rainfall in the two hemispheres. And you can see that the solstitial heating in the warm pool region remains fairly constant, whereas over the Indian monsoon zone, the Indian Ocean region, it shows a strong seasonality. And here in the eastern, whoops, I don't know why it does the damn thing. So in the Atlantic region or Amazonia, it shows some seasonality as well. Whereas if you go to 25 north, you will see the strong seasonality of the East Asian monsoon producing massive heating in the Indian Ocean sector, essentially during the summer, whereas the heating is not that significant anywhere else along that latitude band. And there are of course corresponding changes in the net radiative heating, which shows strong seasonality at 25 north compared to the equator, as you can imagine. The angle of the sun is going to matter for the seasonality of the net radiative heating. So on the equator it's not that dramatic, but at 25 north it's going to become more contrasted in terms of season. So that's the net columnar heating that's going to result again at 25 north. Massive seasonal cycle in the tropics, not such a strong seasonal cycle. This also explains the near barotropic structure, lack of vertical shear, lack of strong vertical shear, and so on. So in your head now you have to start connecting these different ideas. Okay, maybe I should conclude the podcast with this map of total columnar heating for different seasons, and you can see the ITCZ, West Indo-Pacific warm pool, the rainfall and the heating over the maritime continent, which was called the boiler box by Ramage in the 1960s, and the typical marine ITCZ here in the Indian Ocean, which gets split by the monsoonal circulation during the summer monsoon here. So these are the intermonsoon seasons or the equinoctial seasons, and you can see that there is very strong rainfall related heating of the air column here in the summer months because of the Indian monsoon and the East Asian monsoon, and the shift of the warm pool sea surface temperatures, if you remember, and the rainfall, whereas the Indian Ocean remains warm and holds on to the marine ITCZ here, and there are corresponding shifts in the ITCZ in the East Pacific as well. You can see it's much stronger here with the sun being in this hemisphere, weaker, and the waxing and waning of the Amazonian rainfall with the latitudinal shifts. Okay, so when we looked at the land rainfall and looked more in the southern hemisphere, you can see the contributions coming from these regions south of the equator here. Okay, so maritime continent is one and Amazonia is the other one. Okay, so heating, rainfall, and the circulation are all related. We will see later on the freshwater fluxes in terms of evaporation and precipitation. The scales of those are not so easy to explain. Why is the rainfall distributed the way it is? Why is evaporation happening over these regions? Which is related to the Hadley cell, but that's a circular argument. Why is Hadley cell having the strong convergence here and the sinking subsidence over here? And those determine the deserts on land as well. So we don't explain everything in great detail, but at least we can explain why the processes are able to explain what we observe. in terms of the heating and the precipitation, moisture, evaporation, convergence, etc. So it's mostly a consistency check in some sense, taking the observations and explaining the processes of hydrological and heat exchanges that go with the observed distributions of rainfall, evaporation, and the heating and the cooling.